Chapter 2.6, it's algebraic proofs. And you might not remember this because this comes from chapter 1 in algebra, but we have all of these algebraic properties. And we have the addition property of equality, the subtraction property of equality, multiplication, division. We have the reflexive, symmetric, transitive, substitution, and distributive property. And so we need to be reminded of this because we're going to be using all of these properties as reasons for our proofs. And so what does the addition property allow us to do? It allows us to take an equation and add the same number to both sides, right? That still maintains the equality. So then we have the subtraction property, which allows us to take an equation and subtract the same number from both sides. We have the multiplication property, which allows us to multiply both sides of an equation by the same number, c, in this example. And then we have the division property, which allows us to divide both sides by the same number. And so we've performed all these operations in algebra, and these are the reasons why we're able to do so. We have the reflexive property of equality. It's same number is equal to the same number. Reflexive property is not going to be used in our proofs for the next, I think, 3 chapters or so, or 3 subchapters, but it's going to be important when we go to prove triangle congruence. Okay, so we have to come back to this one, but just ignore it for now. And then we have symmetric property, and so I'm going to put a star next to the reflexive property just to remember that we can ignore it for now. Then we have the symmetric property of equality, which says that if A is equal to B, then B is equal to A. Right? What does that allow us to do? It allows us to take an equation like 5 is equal to x and then flip the equation around to x is equal to 5. And you might be thinking like, well, that's just reflexive property, right? But reflexive property is same number is equal to the same number. Okay. In this case, we have 2 different expressions on both sides of the equal sign, and symmetric lets us flip it around. And so when are we going to use symmetric? It's when we're working through our proof and we get to an expression that looks like this, but we need to prove this, right? And so in your mind, it might be like, well, we just write it as x is equal to 5. But when we write our proofs, every single step needs to be taken, and every single step needs to have a reason. So if we end up with this, in order to get from 5 is equal to x is equal to 5, we have to use symmetric property. So this is going to be used quite a bit. Then we have the transitive property of equality. If A is equal to B and B is equal to C, then A is equal to C. Right? This is also used quite a bit. And so what does this mean? This means if x is equal to y and y is equal to 5, then we can say x is equal to 5 by transitive property, right? 1 is equal to 2, 2 is equal to 3, then that means 1 is equal to 3, right? Or statement 1 is, or expression 1 is equal to expression 3, or x is equal to 5. Then we have the substitution property. This is used the most out of all of the reasons, right? And what does it say? It means if we have any expression A is equal to another expression B, then we can replace A with B anywhere we see it. Okay, so substitution property, I'll show you many examples in the proofs down below. Then we have the distributive property, and so if we have A is multiplied by the sum of B and C, right, so we have parentheses there, then it's equal to the distribution, so it's A times B plus A times C, right? So the reason why we're able to do this is because of distributive property. So let's go ahead and go through the examples, and then I'll show you the answers for the practice. Actually, let me go ahead and just stop the video here, and then we could do the examples in the next video.